for coming to our Industry Spotlight series. My name is Shannon Osborne. I work here in the department as the External Relations Liaison. I'm excited to welcome Holly Johnson from MDA here to speak with us about her exciting career in the space industry and all the things that she's done. Holly was actually one of my student volunteers here a number of years ago, helping us to recruit incoming students and things like that. So I wasn't surprised to get an update on her career in the last year or so of all the amazing things that she's doing. She was definitely one of those students that we knew was going places. So she's been at MDA since her PEY position, where she started working in a more technical robotics role and is now moved up the ladder and is essentially running the place from the reference letters that we just received for Holly. These letters came in as part of an early career award package, and I'm super excited to share that we just told Holly today that she has been awarded U of T Engineering's Early Career Award for the year, which recognizes accomplishments of graduates 10 years out or less. So round of applause for Holly. And I am really excited to hear your story and everything you have to share.
Excellent. Thank you. Thank you so much, Shannon. And thanks for having me. I was saying it's been 9 years, probably since around these months that I was last writing my final exams and graduating. Time flies, but I actually do attest that time flies when you're having fun. So thanks for the wonderful introduction, Shannon. As she mentioned, I started engineering at U of T back in 2005. I was MechE 0T9 plus PEY, I guess is the terminology that we say. And so I did start my PEY at MDA. I had the privilege of doing a 16-month internship at MDA, and I'm still there. So over the past few years, I did, throughout my career there, I was 6 years in engineering, working on a variety of projects that I'll talk about today. I did 2 years in business development, which was using my engineering skills and engaging with customers and trying to pursue new opportunities for robotics and automation out of the robotics group in Brampton. And then this past year, I started a leadership kind of internship where I spent a few years working directly with the group president. So our group president, Mike Greenlee, runs the entire MDA company, so 1,900-person company across Canada. The division that I grew up in robotics in Brampton, is just one division of that company. But I've been working with Mike for 1 year now, and it is a leadership development position. So the idea is that I work closely with him and his team. I run certain projects and engage with his vice presidents across the country, and engage with our parent company, Maxar, as well. And then after that 1 year, I would go back into the business and run a certain aspect of the business, whether that's a line of business or a site. It's basically to get accelerated exposure to corporate leadership and then to go back into business. As part of that year, it's been an exciting year for me, and we'll talk to that a little going forward. But as part of this past year, one of the big projects that I've been involved in is advocating for increased investment and in Canada in the space sector. So prior to kind of recently, we didn't have a long-term space plan in Canada. We all have a historic history in space in Canada. There's many projects that we can be proud of, but it wasn't really a priority for the government over the past little while. And so this past year, I've been part of a campaign and a group that we kind of rallied the country. We engage with industry, we engage with Canadians, and to try and inform them and educate them of Canada's history in space, and to encourage increased investment and to pursue future projects in the space industry. So that's kind of been what I've been busy with, part of what I've been busy with the past year. As part of that, I got to go around the country and do speeches to educate people on Canada's history and our place in space. I'm going to use some of that structure today to kind of give you a background of where we have come in space within Canada. But my career actually is kind of embedded and woven into some of those projects, so I'll touch upon those as we go. So as you can see, space was kind of in my blood right from the beginning. When I was a child, I think less than 9, I went to Florida on a road trip, and we had the opportunity. It was just coincidental at the time that we got to see a space shuttle launch. Now the space shuttle is retired now, but that was a phenomenal experience for me. I remember sitting on the side of the road, getting out of the minivan with my parents and looking and watching the space shuttle launch, and that really resonated with me. The idea that we could send humans into Earth's orbit. They can go up and build space stations up there and then come down and land back on Earth within a few weeks. This is a picture of me, a few pictures of me visiting the Kennedy Space Center and that experience down there. When I came home, I made my mom redecorate my room, which is the right-hand side of these photos. She brought home a projector and drew the space shuttle and an astronaut on the top right-hand side. We went on to sell that house a few years later, and I can say that those pictures didn't make it to the real estate listings, but it really shows you that as a child, it was a passion of mine to kind of pursue education and possibly a career in space. One thing though is that when you're exposed to this as a child, based on the flags that you see in those pictures, it was always my idea and my impression that I had to go south of the border or somewhere else to work in space. I'd have to go to a university or a college in the United States and I'd try and get a job at NASA. That was my mindset growing up, and I was thinking that, well, that's what you have to do if you want to work in the space industry. Over the next little while, you'll see that that wasn't true. It turns out that I didn't actually have to move away from my hometown. So the past few years I've been working at MDA in Brampton, which is the hometown I grew up in. So pretty neat to actually grow up through that as a child, understand that Canada does have an iconic history in space, and there is opportunity for us and for you to pursue a career in space if that's your passion. So back a bit of history in space. Canada was actually the third country into space. So in 1962, Canada launched the Alouette satellite. It was a scientific satellite designed to study the ionosphere. A very complex satellite. It was only designed to last 1 year to take measurements of the ionosphere. It ended up performing successful measurements for more than 10 years. So it really shows the reliability that the engineers within Canada were able to gain on this historic mission. 1962, we were the third country into space, behind only the United States and the USSR at the time. So about more than 50 years ago. Another first, so 1972, Canada was the first country to have a domestic telecommunications capability in a satellite called the ANIC. This satellite here had 12 transponders, which means you could get 12 television channels. So compare that to the Netflix of today, it's maybe not a comparison, but having that industrial capability within Canada to launch that satellite and to do that as part of Telesat, which is now the fourth largest space communications company in the world. Telesat was born back in 1969 out of an act of parliament and was a crown corporation at the time. But still a very successful company now, and now a private company, and doing excellent projects and very exciting things that I'll talk about in the future. So my company, MDA, was actually started in 1969 as well. So over on the West Coast, our founders, Vern Detweiler and John McDonald, they wanted to create a company that would retain engineering talent within Canada, and specifically on the West Coast. They were working at the University of British Columbia. They were frustrated seeing engineers get their education in Canada and then go south of the border to try and find jobs. So they started a company called MDA in 1969, and their focus up front was on ground stations, so you see here. The idea of remote sensing satellites, so satellites that take images and monitor the Earth. In order to get that information down from the satellites and distribute it to commercial or government customers, you need ground stations. And so they first got their start in developing ground stations on the West Coast. That was 50 years ago. We actually celebrated our 50th anniversary just last month. And now today, MDA is a pan-Canadian company. We employ almost 2,000 people across the country with sites in British Columbia, Ontario, Quebec, and Halifax, Nova Scotia. And very an iconic Canadian success story, as we'll see going forward. Also in 1969, another historic moment. While many people were tuning in to watch Neil Armstrong's first steps on the moon back in July 1969, there were engineers celebrating a different cause, a different moment on that same mission. So many people don't know that Montreal engineers from Aerodevtech designed and built the landing gear and the legs of the Apollo lunar lander that touched down on the surface the first time. So we often chuckle that it's funny that the first steps, the first imprints on the moon on that July were actually Canadian. So a lesser known fact, but still adding to our credibility as a spacefaring nation with strong space technology heritage. From one of the lesser known facts to maybe one of the more iconic contributions that Canada has had to the space industry, this is the Canadarm. The Canadarm was voted to be the most famous technological achievement according to Canadians in 2008, and many of us know the history of the Canadarm. The Canadarm was launched on the space shuttle mission, so that same space shuttle mission that I observed when I was a child on a road trip with my family. The original Canadarm-1 would go up with every space shuttle launch, and space shuttle launch would go on for or mission would go on for a few weeks and then return back to Earth. So in total, we built 5 Canadarms. The Canadarm-1 had 30 years of missions on the space shuttle, and the space shuttle program retired in 2011. And so the original Canadarm retired in 2011 as well. The original purpose of the Canadarm was to deploy satellites and to retrieve satellites. But as you know, with any good multi-purpose tool and a bunch of engineers and astronauts that have access to it, it eventually accomplished many more feats, including assembling the International Space Station, performing troubleshooting on the International Space Station, and even servicing the Hubble Space Telescope, which we can see right here. So a pretty iconic technology from Canada that was designed, built in Canada. So as a PEY student in 2008 to 2009, when I applied to MDA, I knew that they were the developer of the Canadarm. I didn't know that I would get a chance to work on it, so I went to join MDA in May of 2008, and I was put on the mission support team for the Canadarm program. Now this is really interesting to me because as a student, you always think, or I always thought, that you're going to go into the workforce and you're going to design things. I'm going to build the next generation Wajubi, or I'm going to design the fastest car. But what I learned from this program was that there's a large team that just supports the operation of engineering technology. So the Canadarm program, while we did design the robotic system and we built it, there was many hundreds of jobs that were created that lasted tens of years and decades that just supported this mission. So I would work alongside colleagues that would go down to mission support in NASA, that would sit on console and actually work with their NASA colleagues and do mission support for the Canadarm. That was really interesting to me because the types of engineering skills you think that you're going to apply in designing something brand new in CAD maybe, you still needed those skills, but it was applying them in a different way. And so it introduced me to the idea that there's different phases of projects, that you're not always designing something, but the operations and maintainability of a system is also just as critical as designing something new. I really enjoyed my time there. It was very fascinating to me, and I learned a lot. Like many people will say, the opportunity is what you make of it. I truly believe PEY, if any of you have had a chance to do PEY or any co-op term over the summertime, to really just jump in with both feet. The opportunity I had on the Canadarm program was only limited by my ability to jump in, and so I made the determination at the very beginning. I said I want to take as much out of this opportunity that I can, which is the same in any scenario, but especially when you're first starting off. You really want to get your hands dirty and take any task that you're given and just make the most of it. So that was my first 16 months working in the space sector. I could say I almost had my dream job as a PEY student. I liked it enough that I continued, and I went back to MDA after I graduated. So even though the original Canadarm retired in 2011 along with the Space Shuttle program, Canadarm2 and Dexter live on board the International Space Station today. So right now, actually today, there's 3 more astronauts that are launching to the International Space Station. But every day, Canadarm2 and the Dexter robotic system support operations. So they relocate certain modules, they support the crew in spacewalks, or EVA walks as we call them. They'll accept cargo, so when the SpaceX Dragon goes up to the space station, the arm will capture the Dragon, install it onto the space station, and then Dexter will unload things so the astronauts can do science when they're up there. And so that technology lives on board the space station today. But things have advanced over time. So when we flew the first Canadarm on the space shuttle, it was manually controlled from the astronauts sitting inside the space shuttle. So very video game-like with a remote control. You may have your rotation and your translation controls and different limited coding that you could do. But fast forward to today, where the Dexter robot, which is the 2-armed robot on the bottom here, is controlled 100% from ground. So astronauts actually cannot control Dexter on board the station. they'll say that it's funny, they'll wake up some days and notice that the robot's in a different location than when they went to sleep. And that's because people on the ground have been controlling and doing tasks. So it's really a good example of robotics and humans working together to solve problems. It doesn't mean that the robotics is replacing the humans, but they're enabling them to maximize their utility. In this case, the astronauts are doing a lot of science experiments on the space station. So on today, even daily, the Canadarm2 and Dexter will be performing operations. When I graduated from U of T in 2010 and I went back to MDA as a full-time student, I spent a short period of time working on the Canadarm2 program looking at captures, and so trying to understand, using data to assess the alignment that the arm had, the difference in rotation and translation that the arm had with the vehicles that it was capturing. And so we were collecting all this data, and we wanted to understand how the arm was being loaded in terms of forces throughout the joints compared to what we originally designed it to, and that was to assess or validate the lifetime model that we had for it. So again, right back into really exciting work, but enough to keep me hanging around longer after the Canadarm2 program. So another first that I would say Canada celebrated in space has to do with satellites. So maybe some not familiar with this, but Canada built the first commercially based radar satellite. So this is called RadarSat 1. And RadarSat is a specific Earth observation satellite that uses a radar to take images of the Earth. So when you talk about remote sensing or Earth observation, certain satellites will use an optical camera to take pictures of the Earth, and certainly there's a bunch of satellites that are up there today that can take pictures of the Earth to support science and agriculture, for example. But Canada is actually a leader in synthetic aperture radar satellites. We've flown 2 generations of radar satellites, and the unique ability of radar is that it can see through clouds, it can see through weather, and it can see at nighttime. And so, whereas if you're using an optical satellite to take pictures of the Earth, if there's a big storm or if it's cloudy or nighttime, you may not get the level of detail. RadarSat can actually also detect minute changes in elevation, so it's used down to less than a centimeter. It can be used to detect changes in Earth movement with respect to mining operations, with respect to tunnels that are being dug under the ground. It supports natural disaster recovery. It supports ice flow management, maritime domain awareness around our coasts. So Canada is actually a storied history in RadarSat. So this is RadarSat 1 with a cross-Canada photo of the first image of Canada from RadarSat. Another exciting, so continuing on the RadarSat trilogy, I would say, is the 3rd generation of radar satellites. MDA we design these satellites out on our west coast in Richmond, and we build them in our Montreal facility before they get launched. So this year is RadarSat Constellation mission, so essentially the 3rd generation of radar satellites. This is exciting because RCM, as we call it, RadarSat Constellation mission, is actually going to be launching in the coming months. And so the satellites are finished. They are shipped up and headed down to SpaceX for integration, and they'll be launching from SpaceX Vandenberg Air Force Base in the coming months. So an exciting, iconic history, one of those moments in history, again, for Canada to launch 3 more satellites under the radar spectrum. Here's a photo of one of the last radar satellites that was in our facility. I think this was from last summer. You may recognize our Prime Minister Trudeau visiting the satellites, learning about how they're made. But our integration facility in Montreal is really exciting. So while in Brampton and MDA we focus on robotics and automation, the facility in Montreal develops technologies. They manufacture and design technologies for satellites, both communication satellites as well as Earth observation satellites. And so here's a photo of the final integration in the test facility of the satellite before it was closed up and shipped to SpaceX. So while those satellites observe the Earth, supporting things such as agriculture, maritime domain awareness, security, so they're used in surveillance operations, there's also something called surveilling space or observing space. And so Canada is a world leader in space-based surveillance of space. And so what that means is that we have a satellite called Sapphire. It is in low Earth orbit, which is the closest orbit to Earth. But it has a lens or a sensor that looks out into geosynchronous orbit, or out into a further orbit away from Earth. And basically it's monitoring space debris and space objects and satellites and spent rocket boosters. And the reason for that is that, as you may have heard over the past few years, there's more and more objects being launched into space. More satellites, more debris. When satellites run out of fuel, maybe they're just stuck in the orbit and they're just derelict right there. When you launch anything, you also have little pieces that come off, so bolts and flecks of paint come off some of the boosters. And so this, around our Earth, in different orbits, we have a large and increasing level of objects. And so we actually have a satellite called Sapphire that was launched in 2013 that monitors objects, tracks them, can identify them, and then feeds that data into global situational awareness feeds, such as that for NORAD, to monitor satellites and objects in orbit to make sure that there's nothing going to crash into each other. And so there's a lot of work that's going into understanding the different orbits of these objects, and Sapphire provides one of those data feeds that will go into the global situational awareness for that. Another area which Canada is proud to be a part of is exploration. And so over the past 10 years, we've actually had instruments or aspects of rovers that have been working on the surface of Mars. Over here on the left-hand side, this is the Mars Curiosity rover. I believe it landed in 2012. And as part of that, MDA built, in partnership with academia, a sensor called APXS, which is Alpha Particle X-ray Spectrometer, which is basically learning about the composition of the red planet. And so it was mounted on the end of a robotic arm on that rover. This is a rover taking, I think, a selfie, so we don't actually see the sensor, so I put a picture up at the top. The APXS is that the center rectangular sensor right there. And so what would happen is that once the Curiosity landed in 2012, the sensor was used to take samples and understand the composition of the dust and the dirt on Mars. And so that's been operating ever since. Most recently, and also a very exciting time, we've also built the mobility system for the next Mars rover. So this is a very significant opportunity. Besides NASA and other government agencies, there hasn't been a company that has provided the mobility system for a Mars rover, for the past Mars rovers. And so here we have the wheels and the structure that make up the mobility system for the ESA Mars rover. It will launch in 2020. And this photo was actually just taken a few weeks ago. We shipped this system recently, I think even last week, to ESA for final integration. And this is our team in the clean room wearing their clean hats and their garbs to maintain cleanliness within the clean room. But also exciting to have such a major role in a future space mission to Mars that will continue to find out more about the red planet and look for signs of life and support sample returns back to Earth. So another exciting, maybe lesser known area of history that Canada has played a part in space. So beyond those missions, many people don't realize that space technology provides everyday benefits. So a recent study suggested that space technology touches the lives of Canadians some 20 to 30 times a day. So whether it's using GPS for location or weather prediction, mapping, or even the food that we eat, which is sometimes grown with precision agriculture using satellite data. Space technology not only benefits those that work in the sector and creates phenomenal mission opportunities for Canada to be a part of, but it also provides technology spin-offs down here on Earth. So one of those areas is medical robotics. So this here is Paige. Paige was the first patient to have brain surgery performed by a robot. So this robot in the bottom right-hand side is called NeuroArm. And when I graduated from U of T and I went back after working on Canadarm2 program, the first major program I worked on from start to finish was the NeuroArm program. You go back to the company that's known for space and your manager says, okay, we're gonna do medical robotics. And the first thing that came to my mind was, oh, I didn't take biology in high school, like how am I gonna do this? But what's interesting is that as you go along and you go through the design cycle and you understand the use and you understand the requirements, the ability to build something that works in space has many similarities to building something that works in other extreme environments. So for example, a medical robot has to work closely with humans, just like the astronaut has to work closely with the Canadarm. It needs to be really safe. So you need to show that it's very reliable. It has safety algorithms. In many cases, it's redundant in its safety algorithm, so it can't, even if it fails, it has to fail in a graceful period that doesn't harm the patient or the astronaut next to it. It has to work first time and consistently, so it has to be very reliable. Oftentimes it's in a constrained environment. So in space, you get major temperature fluctuations. Sometimes if you're outside of the Earth's atmosphere, you'll get radiation that you have to design to. In a medical robotic system like this, we designed it to work within an MRI bore. And so there's limitations. As you know, if you've had an MRI, they ask you, do you have any metal on you? Do you have any piercings or jewelry? You have to take that off. Because certain metals, anything metallic for certain, you aren't allowed to bring into a bore, an MRI. And so when you're designing these things, you realize as you go through, there's actually many similarities to designing something for space and designing something for medical. The same thing applies to nuclear power. It's very similar. And so I went through that process. I spent 4 years doing kind of the operational definition of how we're going to use it. Then you do the requirements, and then you do preliminary design with the lead engineers. And then you start manufacturing and assembling and testing and validating that it's going to work. So it was a great opportunity for me. Even though I went back and I was a space fan all along, it was a fantastic opportunity to go through the full design cycle of something, to understand what hiccups can go wrong and where you have to kind of pay attention along the way to go through that full cycle. Sometimes in space you don't get that. Space programs can sometimes be many, many years to design and develop something, and often people that work in aerospace or space in general, they'll commit a portion of their life to designing the next fighter jet, for example, and it'll take 15 years and then they'll go on and do another job and they'll never actually see it fly. So this was a great opportunity working at MDA, because you got access to and exposure to that design cycle to gain that knowledge of how it works, to go through that process. So a really, really fantastic opportunity for me. Another area of medical robotics, this is the most recent project that I worked on as an engineer. We actually partnered with a company called Synaptive, and they started out of the Mars building. I think they've graduated from the Mars building now, but they were a startup company when we first started working with them. They were around 8 people, and they really wanted to modernize minimally invasive brain surgery. So I'll spare you some of the gore, but when you have a deep brain tumor, in order to get access to the deep brain tumor, usually you have to remove a bunch of tissue in order to get access to it. So they had, there's a procedure called port-based brain surgery, where you essentially take a narrow tube down, and the tools go down in the tube to kind of protect the surrounding tissue. So you get access to the tumor, but you don't disrupt much of the tissue around it. And so the problem with that is that you have a very narrow opening. And when you have surgeons' tools that are kind of down that opening, you have very low visibility. You can't really see what's going on. Currently, or previously to this concept, they would place a camera above the surgical site to try and magnify it on a screen, so the surgeon could operate by looking on a screen. But as the patient or the site moved, or the surgeon wanted to get a better view, it really kind of, the system broke down and you couldn't get a clear view. So what we did was we actually put the camera on the end of a robotic arm. And so the robotic arm was designed, it was just an industrial robotic arm, but we applied our motion control algorithms from the Canadarm and put it on the robotic arm. And so it was proven to be safe, and we had to adapt and tweak some of the parameters. But what happened was that we put trackers, optical trackers, on the surgeon's tool, and so every time the surgeon would move the port, the robotic arm could automatically track the location and the orientation of that port. So you improved the workflow of the surgery, you improved the outcome, and oftentimes the speed of the surgery could be greatly increased, so the surgery time was reduced, improving, you're able to do many more surgeries in the same day. And so this was one of the last programs I worked on as an engineer, again in the medical field, but interesting how the safety, the regulatory aspects, the reliability still relates to a lot of the space knowledge that I had gained from the Canadarm programs. A neat story actually, Synaptive has grown up over the past few years, so we started working with them with around 8 people, and I think now they're over 200 people, and so it's neat to work with a startup company like that. Bring your knowledge and IP that you have from space and really apply it into an area that's making life better here on Earth. Another benefit of the space program many people don't know, but our astronaut program actually comes for free when we contribute certain elements to space exploration missions. And so over the past 30 years, when we've contributed Canadarm1 and Canadarm2 to the international collaboration missions, they give you essentially tickets to fly astronauts. And so we've flown 17 astronaut flights over the past 35 years. We actually have a Canadian astronaut up there today, David St. Jacques on the right-hand side, was launched a few months ago. And the left-hand side is our current astronaut corps. And so the ability to be able to have astronauts is one that ties to inspiration and motivation. They really inspire Canadians. And when you go in and you talk to school children, they might think that I have some exciting stories, but when I come with my friend Jeremy Hansen, who's wearing a blue flight suit, they really don't want to talk to me about my robotics. They want to talk to Jeremy. And so it really gets people excited and engaged in space from a young age, which I can say from my experience when I saw that mission and I went and stood behind the astronaut photo. It's really a touching moment that engages you into this sector. And that's something that comes with our contribution to these missions. So another important aspect of participating in space. And of course, space generates strong national pride. So aside from our astronaut program and the iconic missions that I've kind of described over the past little while, they appear on some tokens that we carry with us throughout the day. So I don't know if many of you know, but the $5 bill actually has Canadarm2 and Dexter on the back of it. So if I ever run out of business cards, I always pull out the $5 bill and say, this is my most expensive business card, because it actually has the robotic system on the back. The $100 bill actually has a RadarSat on the back of it. So it really is a inspirational thread that goes through kind of Canadian culture. As part of my work these past few months and working with Mike, our president, we went out and we did some polls. Ipsos did some polling of Canadians to really understand what they care about space and if they're proud. And it was amazing that if people knew about our accomplishments in space, they were very proud of it. But those that didn't, once we educated them about that and the different missions that we've been involved in and really the ability for us to punch above our weight. So Canada is a smaller country than the United States, for example. We have a smaller budget than the United States, but we really have the ability, or we have shown, that we can take that reduced budget and really make a large impact on the international space stage. So people are very proud of that, and I think it shows up in our different icons, whether it's on coins or money or even stamps with our astronauts and our robotics. So another benefit of having that sector is that you build up an industrial base. And so for you, as students that potentially might want to work in the space industry, that's a good thing. If there's a strong industrial base in an area such as space, then there's many opportunities for you to go and potentially work in the sector once you graduate. And so MDA, the company that I work in, is proud to be kind of the anchor of the space sector within Canada. So we're the largest space company. As I mentioned before, we have around 1,900 employees across Canada. Major sites in Vancouver, Brampton, Ottawa, Montreal, and Halifax. But beyond that, we participate in these programs, but as we'll see a bit further on, there's actually a large team that we work with. It's not just us, we work with a lot of suppliers and subcontractors. So we're happy to be a major part of that story, but there's many opportunities outside of MDA to work in the space sector as well. So at MDA, we said we had 1,900 employees. Just to give you a flavor of the type of work, more than almost 1,300, I would say, so almost 67 to 70% are high-tech or STEM jobs that we call. So a lot of engineers, a high percentage of engineers, technologists, generally in the areas of mechanical engineering, electrical engineering, controls engineering, computer science, systems engineering. We have a diverse background, so people have different levels of degrees. Many people come right after their bachelor's. Many people have masters of engineering or applied science. We have a few PhDs that work there as well. So a bunch of different flavors of engineering and different backgrounds, but a very strong technical workforce with many exciting opportunities to work on different projects. So when I spoke before about we're the anchor of the space sector within Canada, the reason why we can do that is that we have this fantastic industrial base that supports us. And so across Canada, we have over 700 subcontractors and suppliers. And so whenever we participate in one of these missions, or designing the next satellite or the next robotic arm, we don't do it on our own. We use a lot of partnerships across Canada that specialize in different areas, and so it really is a group effort, and anytime we get the chance to, we employ that large, broad stroke capability across Canada. So I've given a kind of an overview about some of our history in space and where Canada has played and really punched above its weight. But when we look at the space sector today, I don't know if many of you follow the news and what's going on in space, but there's really two thrusts that's happening. And so when we look at our neighborhood, there's Earth, the moon, and then eventually onto Mars. The programs that I've talked about until now have been largely government-led. They've been funded by NASA or CSA or European Space Agency or the Japanese Space Agency. There's been a lot of institutional government missions into space. And that's great, and that's wonderful. It's given us our iconic missions. But what that's done is it's paved the way for an increased commercial opportunity in space. And so sometimes you'll hear the new space economy or commercialization of low Earth orbit. And what that means is that we've gotten to a place, thanks to companies such as SpaceX, which is drastically reducing the cost to get to space. So launches used to be hundreds and hundreds of millions of dollars, and now they're still expensive for the average person, but they're more in the tens of millions of dollars. And so it increases the access to space for companies. And so what's happening is that there's two thrusts. The institutions and the government missions are focused beyond Earth. So they want to go to Mars. They're clear that they want to eventually set human foot onto Mars in the 2030s or the 2040s, and they're going to use the moon to get there. So they want to go to the moon, go back to the moon. If you listen to NASA's Jim Bridenstine speak, he says we want to go forward to the moon. He says because we landed back on the moon many, many years ago, 50 years ago actually, this July, and we haven't really made anything much of that. And so they want to say we want to go forward to the moon. We want to go to the moon and we want to live there. We want to have astronauts and robotics there persistently. And we're going to use that and go on to Mars. And so that's the governments and the exploration agencies of the world are setting their sights onto Mars. At the same time, though, around Earth, we're getting this emerging economy of business-to-business interactions, many exciting new areas that are happening in orbit. And so we'll talk about that over the next few minutes. And that's what we generally call the new space economy. So it's becoming an economy. It's no longer where governments go. So one area that is kind of important in that is the idea of constellations. And so you hear about satellite constellations. And that just means that instead of having one satellite that's in a really, really high orbit that has large coverage of the Earth, we're launching many, many hundreds of satellites. And so the idea is that if you make a satellite smaller and simpler, they're therefore cheaper, and you need more, but you can cover larger areas of the Earth instead of just one that's much higher up. So what would happen previously is that we make an exquisite satellite that would last 15 to 20 years, and it would be positioned 36,000 kilometers away, and we'd expect it to operate for 15 or 20 years, and it would be hundreds of millions of dollars to get there. But if you make them smaller and cheaper and say, you know what, I'm okay with 5% of them failing, I'm just going to build in that reliability to the numbers that I have, you can create a constellation of satellites. And so that constellation is happening in two areas. One is Earth observation, so the same thing. Satellites that have sensors that take pictures of the Earth that then get downloaded through a ground station and then dispersed to either government or commercial customers. So that's Earth observation satellites. But also in telecommunication. And so there's a few companies out there. OneWeb is one of them. Telesat, our strong Canadian company, is another one that's planning to send up hundreds of satellites to provide internet access to all of the areas that don't have internet access around the world. So we're lucky here in Toronto or around the GTA, you go and you have internet access. There's many regions, even within Canada, even within Ontario, you don't have to go very far where you don't have reliable internet access. And so OneWeb, the company, wants to create internet access around the globe, and Telesat has similar ideas. So Telesat, the Canadian company, is leading one of the largest space communications projects in the coming years, a multi-billion-dollar project to put a few hundred satellites up there. And this is just a notional picture, but essentially you have hundreds of satellites orbiting the Earth, talking to each other and sending data down and providing internet to areas that don't have it. So that's an interesting aspect of the new space economy related to communications that ties to Telesat's history They've been around for 50 years and now have the ability to participate in this project and actually lead this project. So what happened? So with Constellations, when we talk about a few hundred satellites now, a few thousand satellites, this is a new, an emerging, exploding number. I read an article yesterday, I think it was, that there's over 12,000 satellites that are approved to be launched in the next few years. And so when we go from a few thousand satellites to 12,000 over the next few years, that changes things. And so one, you have to be very concerned with where those satellites are placed, what their orbits are, making sure they don't collide with each other, regulating when they can launch and what spectrum they can use. But one interesting aspect of that, which ties to some of the capabilities we have in Canada and at MDA, is the ability to service those satellites. And so up until now, when you have a satellite, like I said, we build an exquisite satellite, a few $100 million, we launch it up there. We hope that it works perfectly for 15 or 20 years because all of our revenue is coming based on that one satellite. If anything goes wrong, you can't go fix it. If it runs out of fuel, which they always do, you can't go refuel it. It just sits there. Sometimes it'll leave a little bit of fuel to deorbit itself, to burn up in the atmosphere. Sometimes it'll increase its orbit and go into a graveyard orbit, so it's kind of away from the rest of the traffic. But it's the same thing, the same concept as driving your car, running out of fuel, parking it on the side of the 401, and then getting off and going buying a new car. So with the capabilities that we have, though, in robotics and dexterous robotics and operating systems in orbit, the idea of on-orbit servicing, or going up and servicing these satellites, whether it's upgrading them or refueling them or moving them to a different location, upgrading their payloads or putting new batteries on, this whole idea is enabled by robotics. It's hard to imagine doing that without some sort of robotics spacecraft. And so while the opportunity is increasing to have more constellations, which gives us better internet, more coverage around the Earth, better understanding of the Earth in terms of Earth observation, there's also an emerging opportunity for Canada to participate in an on-orbit servicing economy. A report from NSR predicted that estimated that the value of the on-orbit servicing economy or market is $3 billion. And that's just based on talking to satellite operators and saying, hey, your satellite's going to run out of fuel in a few years. What would it be worth for you to go up and refuel it? So instead of taking the 5 or 10 year lifespan to design and build and procure and launch a satellite and the money that goes with that, we can change the game and we can go refuel or upgrade. And so that's an interesting area that many people didn't envision happening up front. But because of our capabilities in Canada and our history in robotics and remote operations in space, a very neat and exciting opportunity that we could get into in the coming years. One of the maybe more futuristic aspects, but still being talked about a lot, is the idea of space mining or mining asteroids. And so consider the fact that a single asteroid the size of a football field contains between 25 and $50 billion worth of rare precious metals. And so this seems far out, it seems kind of Star Trek-y, but the cost to set up a precious metal mine on Earth usually runs about $1 billion. The cost to do that in space, to have a space mission that will go to an asteroid and mine metals and precious materials from an asteroid and bring it back, is about $2 billion. So it's not an order of magnitude out, and when you're looking at the value of the metals that are there, you can start to see that the business model starts to work out. Here's just a notional idea of the idea of space mining, but many countries around the world are starting to look at space mining as a potential area to get into. So Luxembourg and the United States have recently implemented legal framework to address space mining, to encourage people to look into it. And Luxembourg has recently earmarked over $200 million for companies and investors to go and invest in space technology that addresses space mining. And so in the future, this might be mining asteroids and bringing the metals back to Earth. But when we talk about the exploration missions where you're going to Moon and you're going to Mars, a near-term implementation of space mining might be that you're just mining for ice, taking that ice, turning it into hydrogen and oxygen, and then using that to breathe for the astronauts or as a fuel to get to Mars. And so that's called in-situ resource utilization. An aspect of space mining, but essentially using the materials and resources that you have to accomplish your tasks. And so interesting futuristic area that we should keep an eye And of course, space tourism. And so, like we've seen, anywhere you develop a place on Earth, it becomes a location that people not only want to live and work, but they want to go visit or take a vacation. So there are interested parties in going to space, traveling to space for a vacation. Right now, the price tag is pretty expensive. So some of these companies, Bigelow and SpaceX and Virgin, are planning space hotels in the 2020s. The costs, the latest cost I read was $792,000 a night. And so probably not accessible to a lot of us, but with increasing access to launch and more competition happening, I think we will see kind of space tourism pick up, certainly in our lifetime. And perhaps one of the most significant and immediate opportunities for Canada to reestablish its leadership in space is what's called the Lunar Gateway. So as I mentioned before, NASA and the international exploration community has set their sight on going to Mars. They want to land humans on Mars. And they're using the moon as a waypoint to get there. So NASA has created what's called a Lunar Gateway mission. They've currently signed off on the ability to fund this mission. And the Lunar Gateway is essentially the next international space station. And so while the current international space station is 400 kilometers from Earth, the next international space station is 400,000 kilometers from Earth. So astronauts will go and visit. We'll send robots, rovers to the surface of the moon. Eventually we'll establish presence on the moon. So the idea is that astronauts will go live and work on the moon. And essentially it'll be a waypoint to build up technology and capability before we go on to Mars. So NASA's leading this initiative. And so really up to the international partners that are currently on the main space team that we look at the International Space Station, so Canada, European Space Agency, Japanese Space Agency, and ESA, to identify what aspects they want to participate in, if they want to participate. So up until a few weeks ago, this would be my last slide that I would have presented in going around the country. And so as a result of all of these opportunities that we talk about, so the new space economy, on-orbit servicing, asteroid mining, the next international space station, Lunar Gateway, there's all of these amazing opportunities, but Canada hasn't had a long-term space strategy for years, and we haven't had increased investments in space. We've actually had declining investments in space for the past 15, 20 years. And so up until, I guess, a few weeks ago, this would be my call to action. Over the past year, I participated, myself with the president and our folks in Ottawa have created a campaign called Don't Let Go Canada. And it's really encouraging Canadians and industry to say, don't let go of our place in space. Don't let go of our leadership in robotics, in Earth observation, in space technology, in satellites. Don't let go of our best and brightest minds. The people that we have here today, maybe you're going to go and maybe you have inspiration to go work in the space industry. If Canada didn't have jobs for you and you really wanted to work in space, you might consider leaving Canada and going to work elsewhere. And so the Don't Let Go tagline is really encouraging industry to sign up and to advocate for increased federal urgency to commit to space and to commit to specifically the Lunar Gateway project, which is NASA's near-term initiative, but eventually further on there's more projects to be involved in. And so it was really a call to action. This would have been my last slide, except 2 weeks ago, we had a really good day. And so we've kind of traipsed around the country the past year and done speeches and engaged with Board of Trade companies. I've done like Canadian Club speeches and met with students and met with industry associations. And 2 weeks ago, Prime Minister Trudeau and Minister Baines, who we see here on the left, and many of the Canadian astronauts assembled at the Canadian Space Agency, and I was invited. And Trudeau said, Canada is stepping up, we're going to the moon. And this was a formal commitment that he made to formally commit Canada to the next 24 years of partnership with NASA on the Lunar Gateway project. And so he committed to provide the next generation of robotics, Canadarm3, to the program and then to operate it for the many years after that. As a result of the distance to Mars, we say that the robotics will need an increased level of autonomy, to the moon. The robotics will need an increased level of autonomy or artificial intelligence, and so we call it AI-based robotics. When you're that far away, you can't operate it with traditional means of sending it commands from Earth. It needs to be smart enough to do its operations around the moon. And so this is an exciting day for everyone involved. It really stands to show that Canada is committed to the space program There's many good opportunities going forward, and it was a very exciting day for me, to say the least, after the past year spending trying to encourage support for this. So again, 2 weeks ago, this would have been my last slide, and which would have been fantastic, and that would have been excellent. But last week was also another important day. The Honourable Navdeep Bains, who was on the left-hand side of the picture before, released a new space strategy for Canada last Wednesday. And so in the context of trying to spend 20 years encouraging the government to look at space and consider it a national strategic asset, Navdeep Bains released the new space strategy called Exploration, Imagination, and Innovation. It uses the commitment of the Lunar Gateway as the cornerstone of that next generation investment, but it also talks about other aspects in terms of using space technology to solve challenging problems on Earth, continuing our astronaut program to inspire youth and engage the next generation of students and inspire them to work in STEM or in space. And so this was, over the past 2 weeks, I would say, it's really a proud moment to see many people recognize that Canada has a strong and storied history in space. We have a lot to be proud of, despite our relative size on the world stage. People are very proud of that internally within Canada and around the world. And so this is a very proud moment for us in the Canadian space sector going forward, to see the federal government commit to space. So as I look through the past 9 years, here's some photos of my journeys along the way. Working with medical robotics, testing systems in the MRI bore. I worked with some police security robotics, using LiDAR systems to map environments and understand situational awareness. This is me recently in front of a lunar lander that Israel launched most recently, and awarded the National Space Hall of Fame, or NeuroArm was inducted into the National Space Technology Hall of Fame. This is awesome, but this is only 9 years. And so looking back at the past 2 weeks and seeing how the government has committed investment and attention to space, I think if anyone's interested in space, I know certainly me, for the rest of my career, it's going to be an excellent, exciting time to be a part of it. But if any of you have any interest in working in the space industry within Canada, I think it means it's very promising. So it's an excellent time to be graduating or near graduation, and I think we should all be proud of that Canada recognize we have a place in space and we're not letting go of it. And so with that, I'll leave you with a quote that Navdeep Bains mentioned at the release of the strategy, which I think is quite appropriate. It says, "By aiming for the moon, we allow our children to reach for the stars. Space represents limitless possibilities and endless discoveries. For every astronaut we send to space, there are thousands of Canadians who are part of their journey. Canada's space strategy will foster our next generation of astronauts, engineers, and scientists, and will ensure Canadians and Canadian businesses benefit from the growing opportunities in the space economy." And so I think that's a nice wrap-up of the opportunity that we have, and I'm extremely proud to say that our country is recognizing that importance, and it's an exciting time to be involved in it, or if you want to be involved in it going forward. So with that, I'm happy to take any questions, and thank you for coming and listening to our story.
So thank you. That was marvelous. Just for anybody who doesn't know me, I'm Marcus Busselman. I'm the chair of Mechanical Industrial. So I just want to say, so Holly's going to be here for a while yet, right? I think we booked this until 2 o'clock, and I think she's going to want to ask or answer questions and talk to you. So I encourage you to stay. I think Shannon just said to me that there may be other students who couldn't come for 12 to 1 who may come in now. I just want to take 2 minutes and just say a few things. I've had the chance to visit MDA in Brampton, and it's a very cool place, right? So to those of you who think about space and working with space and robotics and that kind of thing, it's a great company. But I want to say that I encourage you to stick around and talk to Holly about her journey in getting there, about lessons you might have, or a kind of advice you might have about how to think about going through school, right? To prepare not just for a career in space, but for any cool career, if I can put it that way. I think the other thing I wanted to say was I just sat back there for 45 minutes and listened, and I think you'll agree she's a fabulous storyteller and gave a fabulous presentation. And so to all the students in the room, I also want to say that, you know, an engineering education is about learning all the technical stuff. And I'm sure Holly did really well at that, and apparently, I can't remember, but she tells me I was her fluid mechanics prof a few years ago. But There are other skills that have to be learned, and whether you learn them here or whether you learn them when you get to a position, but Holly has moved. There may be a few of you who weren't in the room when she started, but Holly's just been awarded a Faculty of Engineering Early Career Award. I read the letters that people wrote about her bosses, so to speak, at MBA. And she's a fabulous engineer, but she's moved into a position well beyond engineering now, where where she is training to lead a company like MBA someday. And I really, the letters were just totally amazing. So I think I encourage you to stick around and talk to Holly about space, about MDA, but also about building a career, right? Just more broadly, and about the kind of advice she might have for you, because I think it would be really, really great. So I want to thank you. We have a little gift for you. You know what? I'll leave it over here, and you can take it with you.
Thank you so much.
But I really want to thank you for coming, and do stick around. All right? I do have to leave.
Thank you so much. Nice to see you.
Okay.
Excellent. Thank you. Yeah, so I'm here. I booked my calendar until 2, so no one's going to bug me until 2. So if anyone has questions, I think to talk on Professor Busman's point, the technical aspect of my career and my journey was one aspect. It was a very narrow aspect, and I didn't know that right from the beginning. When I went to my PEY interview, I was a bit intimidated because I knew everyone else that had interviews with MDA, and they were the top 5 people in the class, and none of those were me. I was kind of further down on the rankings of the scale in terms of like technical ability ranking within my class. But right from the very beginning, my very first interview I remember with Ken Martin, who's now the site lead of the division in Brampton, he emphasized that technical understanding is only one very small aspect. And so your engineering career and your engineering knowledge is one important part, and you should take it seriously. But actually being able to make the most of your opportunities, whether it is in engineering and accelerating to senior engineer and staff engineer and just being an expert engineer, the soft skills in terms of being able to communicate your thoughts, being able to respectfully have a discussion and engagement with someone, being able to disagree, and how do you disagree with someone but respectfully counter their thoughts and have a good collaborative discussion, presentation skills. So I can't tell you, like, every day, now my job is all presentations, but even as an engineer, you aren't in especially nowadays, you aren't in a cubicle working on your own engineering project, doing math and writing a report and then submitting it in email and never interacting with humans. That doesn't happen anymore. There are presentations that happen along the way. And so I wasn't an expert presenter at the beginning. It's taken a while, and I've been exposed to different levels of presentations. When I was on my PEY student, they put me up in front of the NASA panel and said, okay, present your technical concepts here. And I did an okay job, but I knew that I had to practice. And no one has all of those skills right out of school. At least I didn't, and many people I've encountered. It's a lifelong journey of learning. So the best thing to do is to take the opportunity that you're given, but acknowledge and understand that you're not, once you graduate, it's actually just the beginning. Like you have a strong foundation, and being at U of T and having that strong educational curriculum, and U of T has a wonderful reputation for being a strong engineering school. It's actually just the beginning. You have to build your personality and your character around that, and it really has to be true to yourself. I knew that I wanted to work in the space industry. It was a passion of mine, but I didn't do it by getting a master's and PhD and saying I have to be a super smart person to work in the space industry. I've been able to work in the space industry. I wasn't the top of my class. I would also say that maybe there's a reason why I was only 6 years in engineering, and maybe said, okay, you should go into something else other than engineering. But I joke about that, but there's often a role. If you have a passion and you commit yourself to a journey of learning and adapting yourself and growing, not only in technical, but also leadership, communication skills, working as a team, there's really fantastic opportunities. And so that's the one thing that I didn't know when I was a student, is that I thought it was all technical and you had to be the top of your class, and it was really important. And it is really important, but there's many other things that complement that. Being a part of a group, extracurricular group, working for a charity. Like when you come to MDA, and you can ask questions about MDA recruitment and jobs there if you want. But they do put a major emphasis not only on your education, but the well-rounded person. they really want people that have interests outside of engineering. So they don't want people that just do engineering and technical and that's all that they do. So any element that you can bring in, whether it's a sports team or a chess club or a student debate group or extracurricular or volunteering with your church or anything that you have, they really want to understand that you are a well-rounded candidate and that you're going to bring that kind of humble knowledge. You want to learn, you want to be a part of something bigger. You're not going to come in expecting that you know everything right from the beginning, because I didn't. And what you'll find is that when you go and you work in industry, the education you have here give you the basis to understand what questions to ask. And you know how to ask the questions, and you kind of can navigate as you go on in your journey. But it won't give you all of the answers on how to do your job. That wouldn't be part of learning if it did. And so you really have to kind of be a sponge and be willing to be humble and ask questions and seek guidance and find a mentor and really learn. And many people expect that. So that no one expects you to graduate and be a working level person that no one needs to give any direction to. And so that would be my, I guess, overall advice, is that technical is important, but it's not everything. Make sure you have well-rounded opportunities and always continue to learn. Even 9 years into working at MBA, I sign up for courses. I want to learn about technical and soft skills and leadership. I take leadership courses when I can, and that is recognized as a very valuable asset and interest if you want to kind of progress in any industry, I would say, as part of your career after you graduate. So if there's any other questions, you can kind of pin me. Oh, before I forget, in case any of you have to leave, I threw some pens and some pins. Feel free to come up and take some if you want. They're just the MDA pins, but I was excited when I was a student to kind of get an MDA token, so feel free to take some if you want, and feel free to leave when you need to. But otherwise, I'll take questions until 2. Yes?
So when you started your PEY, how did you transform into that role since you were a student? Were there like training provided to you? Were there a mentor at work they had, or how did you get into the work?
Yeah, and so it was interesting. I was thinking back when I first went to go to PEY, I remember thinking, I don't even know how business works. Like, is someone going to give me a task? Is someone going to supervise me? Is someone going to direct me on what to do? I didn't understand how just a business environment worked, because I had never been in a business environment before. And so what I found is that people will give you guidance, but the most important thing is to engage and be forward and ask questions. And you'll find people that are really willing to help you. I was really lucky at MDA. There was lots of people that really wanted to help you succeed, and they wanted to teach you and bring you into their project. If you find people like that in your PEY, which I've heard a bunch of my colleagues and previous students that I went to school with had the same experience in other companies, where they said the leader or the mentor really took them under the wing or guided them in a way to say, like, this is how either you do your task, or like I'll bring you along and educate you as you go. But the important part is that you actually have to take that initiative. So for me, I asked to be on projects. I would be doing a task, and the leader would say, okay, now we're going to take this information and take your data that you collected, and I'm going to give it to the senior engineer, and they're going to calculate the rate of rotation. I would say, oh, that's fantastic. Can I be involved in that so I can learn how we do that? And they'd say, sure, like, go ahead. Like, they just wanted you to be enthusiastic and take the initiative to do that. So it's both ways. You'll often get people that will lead you and be good, excellent mentors, but the most important, I found, the most valuable skill or decision that I made was to just jump in and say, I'm going to ask questions, I'm going to ask to be involved in different projects, I'm going to get the most out of this experience that I can. And the PEY one is fantastic because it does give you the opportunity to go 12 or 16 months, I think, if it's still the same as it was when I did it. You really get excellent value. So you can, sure, there's a learning curve, but you start to actually operate like a working level person by the end of it, and you learn an incredible amount during that time. So I really recommend it, but it's what you make of that opportunity by jumping in and asking a lot of questions. I still ask questions. We'll be in board meetings all day, and all of Mike's VPs will be around there, and they'll say something, and I'll say, okay, I need to stop. I need to know what that means. I've never heard of that term before, and no one has ever told me to stop doing that. Like, they just love that you ask questions and you want to understand different people's perspective, and so that would be my recommendation. Yes?
So you talked about when you started working full-time at MDA after graduating,
Yeah.
that you were on the, I guess the medical arm
Yes.
project for a while, for
Yeah.
about 4 years, I think you said.
Yeah.
I had a similar experience when I was working on my master's, that being on one project and feeling kind of siloed and being stuck in that project, did you feel that you were given opportunities to branch out from that, or did you really have to like find them yourself so you knew after that maybe 4 years that you'd be able to move into another role and not feel like you had to move elsewhere?
Yeah, so at MDA, how we work is we work in like a matrix organization. So I have a manager that is responsible for my career development. So a manager that was the lead systems engineer, for example, and so they would be responsible for my career development and what programs I worked on. But I'd also be working on a program, and so I'd have a program manager. And so the one great thing about that kind of structure is that you always have someone, and again, it takes the initiative to have that conversation and to speak up and say, this is what my interests are. But I throughout my 4 years on that program, and even afterwards, I was in frequent communication with my manager, kind of understanding how I was liking my current role, understanding how I was performing in that role, and then planning the next one. And so every time I was in a project, my manager, before I finished that project, always had a view to where I was going next. And it was often to create different experiences that would provide you with different knowledge areas that you wouldn't get if you were just kind of from the lottery, picking out the next job. And so my manager at the time, Ken, who hired me as a PEY student, said it's really important that you go on this medical robotics project. And I said, sure, but like, I don't know anything about medical robotics. But he said, no, you don't understand. He said, 4 years to go from like engaging with the customer to designing it, or to engaging with the customer, to understanding the operation, to defining the requirements, to building it, to testing it, to validating it, to installing it. I spent six weeks down in Minnesota in the freezing cold, in the lab down at the company in Minnetonka, installing it. You really get that exposure, and he had that foresight to say this is important to understand. So MDA has that structure where you have someone that's always monitoring your career growth, as well as a program manager that will be your day-to-day program supervisor, I would say. And so, again, it took the initiative to have those conversations, and at first I wasn't so vocal about it. I wouldn't put my hand up and say, I really want to go work on that next project. I was shy, I kind of kept my head down, I did my work, but I didn't want to speak up and say, this is what I want. But as I kind of grew up through the organization, I'll always tell people that after 6 years in engineering, they posted the position for business development manager, which is the position I eventually got. But at first I didn't apply. So I was, 26 or 27 at the time, and this position came out saying business development manager. And I looked at the job description and I was really excited. It was working at what we call the front end of the business. And so you're working with potential customers and potential clients. You're meeting with different space companies and saying anyone that's interested or has concepts that might benefit from robotics or automation. You're defining concepts, you're putting quick concepts together, estimating the cost, writing a proposal, going to meet with them, and that was really exciting. And I had done part of that as part of a concept study phase that I was working on before. So I was working as an engineer at that level, but I wasn't working as a manager. And so I was in my kind of mid-20s and this posting came out, and I didn't apply, even though I thought it was a fantastic job. And the president of the site at the time actually came to me and said, Holly, I was extremely disappointed to see that you didn't apply to that posting. And I said, what posting? And he said, the manager posting. And it was just ingrained in my mind that, well, I'm in my mid-20s, I can't be a manager. Like, it was just a mental block that I had thought. And he said, well, look at the job requirements. You satisfy all the job requirements, and are you interested in it? And I said, well, of course. Like, this is fantastic for me. And so I ended up submitting my resume the next day, scrambling to like make the deadline, and I eventually accepted that position. But it wasn't something that I had the confidence to do right from the beginning. That process of not applying, someone kind of poking me and saying, hey, like if that's what you want to do, you go apply to that. That whole process really taught me that people actually enjoy when you stand up and tell them what you want to do. It's one thing to have your head down and be recognized for the good work that you're doing, and to be recognized for a project, but it's actually it's fantastic when, as a manager, that I worked as a manager, when you have employees that put their hand up and say, you know what, like I like this, what I'm doing here, but I really want to kind of aim for that direction. How can you help me get there? that's like the best situation to have, because you know where they want to go, they have a passion for it, and you can kind of guide them on the route to get there. And so that's the one thing that I did learn only very recently, was that it's fantastic to stand up and say what you want to do. You may not be able to do that right away, but there'll be people that can help you kind of carve out that path. And everyone has a different journey, so it doesn't mean that you have to follow what someone was doing. When that job came out and it said manager and I was 20-something, I said, well, no one in the company now is 20-something and a manager, so therefore I would never be one. But that happened and I was a manager, and now hopefully people below me that are coming up as juniors will see that it's not impossible. It's just was a circumstance that no one was in that situation. And so I think it's a bit of a long-winded answer to say it is up to you to kind of make the most of that project, but be clear with what you're hoping for at the end of it. And every opportunity is great to learn from, but you kind of have to have a vision to navigate yourself through the journey as you go. Is there any other questions? Yeah, so I'll get back to you. You haven't asked one yet, but I will.
I'd love to hear about some of your biggest leadership challenges over the last few years and how they've helped you to get to where you are today.
Leadership challenges. So I would say, that's a good question. I would say from the past, my entire career actually, a challenge has been that the same challenge that I projected on the world when I was growing up was that people in senior positions, you had to be older to earn that position. And so the challenge that I found myself, being a leader, even as an engineer when I was a leader of a team, I would be leading people that were much older than me. And I succumbed to the same kind of status quo where I said, well, I couldn't be a leader because these people are older than me. That really has to, like for me, it took a while to kind of get over that, and that was my own mental block, saying like, I didn't even apply to that job because I said, well, I'm only 26, I could never have that role. Other people feel the same, like as a younger person, when you are a leader, some people, depending on their background, depending on their experience, depending on their willingness to engage in collaboration, some people won't respect that and won't have the same view. But I find that it's really your responsibility to put yourself in that leadership position. It's how you carry yourself. It's how you run the room. It's how you present. You engage with people, and to be the leader that you think that you are and that you deserve to be, and that you're put in that position to lead. And so usually what happens is those people eventually fall in line. Sometimes it takes a while, but they'll see that everyone's doing it. I've had very positive experiences at MDA. Like people have been very receptive to me being a leader, even though I would be on the younger end of kind of my peer group when I'm working across functions. But I have tremendous respect amongst all of Mike's colleagues right now. Mike Greenley, the president, they're all VP level people that have 20, 30 years experience, but they'll call me and say, Holly, what do you think about this? And so it's really kind of owning your passion and being a leader and having the confidence to do that. Say. Did you have another question?
I'm just referring to one of the photos up there. Do you need to have a professional engineering license?
No, and so it depends on the company, and so certain companies will have different requirements. I know at MDA you do not need to have your PNs to work on any of the projects. Certain projects, the customer may require it, so we would do a project for, I think, the OPG or Bruce Power. We had a nuclear project where they mandated that all the engineers had to, because they needed to sign off on drawings, so you need to have your PNs. But your PNs requires you to have a certain level of experience as an engineer before you even get your PNs. So you certainly don't need to have your PNs to get hired into MDA, because I was hired in without my PN. The work that I did at MDA, because it was technical in nature and I could show that I was following engineering process and using engineering application throughout my day-to-day job, I qualified to get my PN license, but it's definitely not something that's required at MDA. Anything else? Yes?
Is there a possibility of an international student working at MDA? Because I know that they need clearance.
Yeah, so we do have some ITAR clearance, security clearance regulations. Just because some of the projects that we work on are ITAR restricted or there are constraints in what nationality can work on those projects. It doesn't mean that in all the sites across MDA that you cannot work on projects, but it depends on the background. And so HR would be a better answer of that. I can't answer that question, but we do have some constraints based on projects. I don't know if it's across the board, but certain areas, depending on the project and nationality, we can't have that. There is a disconnect there. Yes.
On the space
Yeah.
related side now. So I know the funding that came recently is largely based off the Lunar Gateway project, and although it is maybe, you said for 20 years, how does the possibility of changing administrations in the States and changing directions of NASA affect those projects here at MDA and other companies, and is the funding that Canadian government provided something that's kind of insulated from those changes, where we still need, we'll still produce that technology, we'll still have projects. I know before the funding, it was the question of which projects were available was kind of up in the air. So.
Yeah, no, that's an excellent question actually, and that's something that we would deal with that I would never even think that existed, like the political wind shifting. I would say there's always a risk of political winds, is what we call it, shifting the course of space exploration. And so, as we've seen after the space shuttle was retired, there's a shift in the idea of how are we going to, as a nation in the United States, how are we going to replace that? And so they went through different administrations that kind of shifted between the Orion program, and now they're doing commercial crew vehicles where they're looking at, and we'll actually have commercial vehicles sending astronauts to space. Previous to this latest administration, Trump's administration, the focus was on asteroids. So they wanted to send astronauts to an asteroid and harness the asteroid and bring it back to Earth or Earth's vicinity. But what's interesting is that, sure, there are kind of susceptibilities to kind of change the course in terms of the destination. But what usually happens is that each of the administrations will have kind of their vision, and the technology development to get to that vision is largely the same. It's just the destination that's different. And so the Lunar Gateway is actually very supported in the States right now. So they'll say that they have more money to fund Lunar Gateway than they know what to do with. So they're kind of full steam ahead on Lunar Gateway. But all of that technology has been developed in previous years under a different regime that was still kind of aiming for the same direction. So when you talk about the ability to, for propulsion systems and solar arrays and structures and navigation systems and autonomous vehicles and robotics, you all need to enhance that capability. And whether that system goes to the moon or goes to Mars or goes to an asteroid, sure, there's different kind of requirements that you have to bend to. But I think right now, at least, Lunar Gateway is extremely well supported in the States. Canada has committed to Lunar Gateway, and what happens usually is that you create bilateral agreements within countries. So the United States will sign an agreement with Canada, and then eventually, hopefully, ESA and Japan and other agencies, and they'll create an international agreement that says we're committing to this project. And so it's kind of becomes less susceptible to shift in political winds once you have all these international agreements. Because just like we see with treaties, it's you sign something in between countries, and it kind of transcends the political winds of the time. And so it's something certainly we keep in mind, and you want to monitor it. But as the Lunar Gateway gains momentum and more companies and countries are brought on board, it'll kind of become more static and become a fixed concept that will occur and continue to progress through 24 years as Canada is committed to. So hopefully we can see that will remain. But it's a good question, actually, because you are susceptible to kind of external influences. Yes?
So what are some strategies you employ to build your soft skills?
So, excellent question. It was often not even a direct strategy. So nowadays I'll keep an eye out for courses and opportunities to take kind of a leadership course and learn from other people that have kind of developed these types of things. But often it's just the situations that you find yourself in. And so when I first started MDA, they were looking for someone to lead a Children's Wish charity event. And so it's a charity event. It was for Children's Wish, which dedicates wishes to children who have terminal illness, and so every year they would raise $10,000 and allow a child with terminal illness you grant them a wish, and so it would be to go on a trip to see Mickey Mouse, or to Disney World, or to go to see the space station, or the space mission control, or something like that. And so as a student, not a student, but a new grad at MDA, they were looking for someone to lead that. And in my mind, that was a charity that has a close tie to me. My younger sister spent many, many years at Children's Hospital, sick kids, just local, just here. And so that for me was something that I kind of found I was very passionate about. And so the opportunity came to kind of lead the site's charity event to raise money for that. I didn't think in my mind that, this will give me soft skills and I'll be able to add this to my resume. But what I ended up doing was organizing a team of volunteers. We set up a bunch of events that would have bake sales and music contests and raffle draws and prizes. So I requested a whole bunch of to get people to help along that charity event. Interacted with corporate to say, can we get funding? Can you help us provide prizes? Can we get access to the site? I interacted with the charity, so organizing the team, setting up events, and then we actually ran an event on Toronto Island as part of Exile Island, which was their event at the time. So all of those skills of interacting and engaging with different stakeholders, planning, cost budgeting, financial planning, understanding leading events within the sites, those skills provided me with kind of increased abilities to practice them. But that wasn't something that I intended to go out and do right from the beginning. It was kind of like a byproduct. And so same thing with learning. If you intend to say I need to get my master's degree because I want to work in aerospace, that's kind of the wrong way to look at it. You want to try and engage in the area that you're interested in and understand what you're passionate about and where your actual abilities fit. And so I would say exploit opportunities to follow your passion, but make the most of that opportunity to gain soft skills and management skills and leadership skills. So that mixed with obviously taking courses if you're interested and doing that, it kind of ties it up. But if you just go and take a whole bunch of courses and say, I'm going to be an expert leader now, it's kind of like sitting in the passenger seat driving, saying, well, I'm an expert driver, even though I've never touched the wheel because I've been driven around before. It's a different way of thinking. And so I would say exploit the opportunities to practice those skills. And it is practice. When I was first graduating, I didn't feel confident standing up in front of a room and engaging with people and telling a story. Only now that I've done that more and more times, I've become more comfortable with that. But it's many years later, so it is practice. Whereas some people can do that right off the bat, and they just are experts at it. So I would say exploit the opportunities you have, but following your passion, whether it's in community service or sports or leadership or church or anything. It's make the most of what interests you.
Okay, thank you.
You're welcome. Is there anything else?
On that note, Holly, I have students ask often, how can they get their resume seen? So they're here today, they're inspired, they want to work in space. What's going to make them stand out when they decide to go on the website and apply for a job where their technical skills match up?
So
is it networking? Is it?
Yeah, so I would say there's a few things. So certainly networking helps. If you're interested in if you're interested in any area, whether it's space or mining or anything else, networking, understanding the lay of the land, understanding the major players like the companies and the opportunities that are in that area is important. But I know from the MBA perspective, and I've certainly been involved in reading resumes and cover letters, I would say the important thing that we look for is, again, it's not the 4.0 GPA, it's not the highest ranking in the class, it's really an attention to the passion that someone has for what they're about to do. And so I've read cover letters before that really speak, they really understand, they'll tell a story, they'll say like my story, like I wanted to work in space, or I just came across this opportunity and looking more into it, I engaged and I researched and I found it really kind of suits my personality and what I am interested in, but they have a passion to apply for the job, as opposed to saying, this is just a standard job that I'm going to apply to and here are my credentials and I don't really care if I'm picked or not. Often people will take that defense and say they'll write something as if they're like handing the exact same thing out to 500 companies. It's really important to articulate why you're interested in working for that company, regardless of what company it is. Because someone reading that will say, oh, this person values coming here, they'll make the most out of it, they'll be a valuable member of the team. And that can be through, it doesn't mean to be you need to have a 10-year history, in this case, wanting to work in space. It could just be, I just came across this industry, I'm really excited about the prospects, I've read that Canada is committing, that type of thing, where it shows that you've done a little bit of research in the area, and you're really engaged and passionate about that specific opportunity and how you're going to make the most of it. So as someone who's read resumes and cover letters before, it's really important to kind of tune each one to the specific opportunity you're applying to. It doesn't mean that you can only apply to civil engineering jobs if you want to do that. Like you can adjust it, but make sure that it comes across that you're knowledgeable about the industry or the company, and that maybe if you have a past experience or you saw someone come and do a talk or you've engaged in one of the leadership programs before, any type of indication that you've shown effort and you take the initiative to pursue engagement in that industry or within that company is, I think, helpful. As well as networking, like LinkedIn is fantastic nowadays. I never had that when we were growing up, but it's interesting to see you can kind of network with people. It's not everything though. Like often you'll get connections with people at LinkedIn. If they've never met you, it's kind of hard to kind of have a first impression. So you have to be careful with how you engage with people on LinkedIn. It's not just like a free for all with everything, but it's the same thing. If you show that you're interested, I've had messages from people, even this week, maybe people from in this group that saw that I was coming to speak today and engaged with me on LinkedIn, that I apologize I haven't responded yet, but they're taking the initiative and saying, like, I saw that you're coming to do this talk, I'm interested in this area, I'd like to ask questions, how can you guide me? And if you're here, I apologize I haven't actually responded to that yet, but people will. Like, it is something that I know people place high value on in terms of networking and being involved in the industry. So I hope that helps a little bit.
Any other questions? Anybody want to work in space? No? Okay. You guys are very shy about it.
It's okay if you don't. Like for me, this was my specific passion, and I ended up following it. But it really is a lot of the same lessons apply to regardless of what sector you're interested in. I would say another type of, I would say, overarching principle, I would say, is just stay true to yourself and don't chase something because you think it's a glorified position or it's a big reputation will be associated with it. Just follow what you're interested in. If you follow what you're passionate in and you put effort into it, you'll find that you develop a niche skill, and you won't necessarily follow the same trajectory that anyone else before you did. There's no one at MDA that I could point to that said I followed that path. I followed the same path that they did. That was a struggle I had as a junior engineer growing up, because there was no one that I could point to that I could say I want to end up following that person's career path. But what I found is that by jumping in with both feet, being fully engaged, trying to make the most of the opportunity, you end up making your own path. And then hopefully people that are following you can realize, there wasn't anyone that did that before and she was able to do that, or he was able to do that. And so the same thing would apply. Don't have the end game completely carved out and very specific when you start your journey, whether it's as a student or in the career. Be flexible and be open and talk to people. And it doesn't mean that you think that you want to go work in this industry and you go and you learn a bit about it and maybe you don't want to do that anymore. Maybe you kind of practice or you have a student internship and you change your mind, and that's okay. People change their mind all the time. I thought I was going to be an engineer for 20 years and I only ended up being an engineer for 6. But I needed to know all of that to get to where I am. And so just be flexible and don't have a specific end game in mind. Just be open to whatever kind of comes your way, as long as you're passionate about what you're doing and you're making the most of it. Yes?
So you talked about how your idealized version of engineering was designing a product, and then you said there was a lot of maintenance in the product.
Mm-hmm.
Right? I was just wondering if there was anything apart from that between your idealized version of engineering and what actually engineering is.
Yes. So the biggest, I would say the biggest eye-opener for me, again, it's probably related to the whole design thing, but when I first started working in industry, I was engaging a lot with the customer. And so the customer is a customer that you're designing something for. And so for the DuraArm project, the medical robotic project, I was meeting with surgeons, I was meeting with the operating room staff, I was meeting with nurses, and the idea to engage with someone and to understand how they will use what you are designing is the most important thing that I learned as an engineer. Before, when you're working on like space projects, sometimes you get like a requirements document and it specifies all of the specs that you need and the mass and the volume and the joint torque and the gear ratio and everything. Sometimes you have to derive those requirements yourself. But often what happens when you're engaging in traditional industry or business-to-business interactions is that you'll go talk to someone and they won't speak your language. So they don't know anything about robotics and they don't know gear ratios and they aren't experts in robotics or automation, but they think that a robotic solution could help them with their operation. And so the one important thing I learned was that the importance, and again, this is where the soft skills and engagement with people comes in, is that I'd sit down, I don't know if I have pictures here, I don't have pictures of the surgeons, but I'd be sitting there in the operating room watching brain surgery and really understanding the use of whatever they're going to, you're going to deploy for them, whether it's a robotic system or an automation tracking system. The importance of that is that once you engage in the technical details about requirements and the mass and the volume, if you truly understand how that system is being used, you can start to think and represent the customer's best interests as an engineer. And so in my time at MDA, I graduated here as a mechanical engineer, but I spent most of my time working as a systems engineer. And that just means, I didn't know what that was at the time, what a systems engineer was, but it just means systems engineering is essentially taking a project and breaking it down from like an operational perspective and having to understand and making sure that the mechanical, electrical, control, and user interfaces all work well together. And so at MDA, we have a systems engineering group, and they're responsible for making sure that the system that's designed is usable in the best possible way by the customer. And so you do need to know technically a little bit about software, a little bit about electrical, a little bit about controls, a little bit about mechanical, user interfaces, product assurance, program management. You need to know a little bit about all of that, but it's really representing the customer's best interests. And so not every company employs system engineering, but the whole idea of user-centric design, understanding how the system will be used. You can make the most pristine, perfect engineering marvel and hand it over to the customer, and it won't be usable to them because the engineer at the time or the system designer at the time didn't fully understand what the constraints of that person was in their environment. And so I always encourage, if you're designing something for anyone, whether it's a surgeon, an astronaut, a mill worker, anything else, really understand their world. So go and sit, watch them operate. What are they dealing with? Are they dealing with paper? Are they dealing with a messy environment? What's their workflow? What are constraints that are going to be imposed on whatever you're designing? And only when you truly understand their kind of constraints within their environment can you design something or operate something or support something that will make their life better. And really it's kind of that aspect of making sure that whatever you design, you're going to spend years or sometimes many more years building something, and usually there's a substantial amount of money involved with that. Making sure that it's usable is something that I learned it takes a skill and it takes a continuous engagement with the customer. And so making sure that you really understand. Asking questions, it comes back to asking questions, understanding their world, understanding their operation, and then being able to apply that and make decisions based on what you know about that. And so as a systems engineer, you do that a lot, but I always say that even as a mechanical engineer, industrial engineer, whatever you want, that's a very important skill that will carry you to be very successful in your job, because you're ultimately looking out for the best interests of the customer. So that's one thing that I didn't pay attention to or didn't think of even as a junior, but I learned that along the way. You're welcome. Is there anything else? Anyone want to ask about jobs or recruitment?
So when you were an undergrad, did you pursue any minors or specific streams in mechanical engineering?
Yeah, so I did energy systems and I did machine design. I don't know if they're the same now, they may be different. I didn't actually pursue mechatronics, which would have been helpful. I wish I would have taken more electronics or mechatronics courses. But again, that ties to the idea that I didn't define my every move based on a projected outcome. I made decisions based on what interested me and what were my passions at the time, and I kind of had a long-term view of where I wanted to go, but I wasn't critical and articulate in defining, well, every little step has to add up to this career that I'm planning. I was flexible on where I went, and so in hindsight, I wish I would have taken vibration analysis, which is helpful when you're launching something into space. It undergoes a lot of vibration, and so I still say I may eventually go back and take a vibration course. Mechatronics is helpful, again, in my area, but I didn't take that as a student, and so depending on where you're going, I would say roughly align your interest and your passion with where you want to go, but it doesn't mean that you need a specific course or a specific degree in order to accomplish wherever you're going. Any other questions? I don't know if anyone wants to know about like recruitment or new grad hiring. And so at MDA, we have all of our jobs are posted on a website, so I don't have a list of jobs that are posted today. But if you go to the MDA website, it's mdacorporation.com, or just Google MDA Corporation, and it's actually a relatively user-friendly site now. You can pick the area that you're interested in or the site that you're interested in, so Brampton, Montreal, Vancouver, or you can just leave it all open. And it'll always have the latest positions that are open. Right now, I don't know offhand what levels of or what areas of engineering we're looking for. Across the country, it changes depending on the different projects you're interested in. So I know on the West Coast, we do a lot of defense systems too. So I didn't talk about that in my talk today, but on the West Coast, they do a lot of certainly the Earth observation satellites, but they do other defense areas as well, such as naval sensors and UAV services. So they'll put sensors on a UAV and do kind of surveillance. And so Montreal is our satellite manufacturing facility. Brampton is robotics. We have some more defense work out in Halifax. We have an area in Ottawa that's called Neptech, a small company called Neptech. They're associated with MDA now. We acquired them last year, but they build space sensors and LiDARs. And so across the board, we have a bunch of different areas that we work in. Generally, we hire mechanical engineers, electrical engineers, we have aerospace engineers, we have computer engineers, computer scientists. We do a lot of, because we're building complex systems, there's people with different specialties find kind of unique niche ways, niche areas where they can add value. So we have a PhD that did his work in structural composites, and in spaceflight, when it's really important to be really light, we needed to bring in an expert that really understood composite material, and so he did his PhD in composites and is now working for us doing a lot of our structural analysis. And so those are the main areas that we work in. I know in Brampton, where I grew up in, a lot of control systems engineers, and so motion control of robotic systems. But again, it's because we're designing a whole variety of things. People with different backgrounds are really valuable to us. We also have an area that does systems engineering and operational planning for nuclear power plant shutdown. And so they're not designing any robotics or any automation. They're kind of acting like systems engineers or project engineers to go in, understand the nuclear power plant shutdown procedure, and create procedures and interfaces and project flows in order to minimize the shutdown time to maximize the power that can be generated from that nuclear power plant. And so those people, some of them which I went to school with here, they're mechanical engineers, but they're not deploying their mechanical engineering skills. And so we do take a variety of skill sets. And so the best thing to do if you're interested in working at MDA is to go to the website and see what the requirements are. And it's always changing, different levels and different specialties that we're looking for. Is there any other questions?
We could probably take a few minutes if anybody has any one-on-one questions, because that almost always happens where somebody doesn't want to share with the whole group. So we'll say thank you again to Holly for coming out, and to you guys.
It's wonderful to have your attention for that long. Right? It's amazing that you guys are able to dedicate finish a problem set that was due at 4 p.m. or to study for a test that was tomorrow. So I appreciate you taking the time to come out and spend some time with me. And for sure, if you're interested, you can come up and ask me questions after. Otherwise, thank you so much for coming and talking with me. And good luck on the next journey, wherever you're going. Yes.
Thank you very much. And yeah, there's more food if you guys would like. And if you do have any questions, come take a minute.